Okay. So, so last time we worked on this thing. Um, it's a little 3D printed jig for this magnetic encoder. We didn't actually have a good way to mount it, but it seemed to be held just in place just fine if it wasn't moving around a lot. I'm sure that introduces noise into the readings, but what we're gonna do now is we're gonna take back this breadboard, plug this shit in, plug back in the power. And the idea is just to see if we can detect some skipped steps, and if we can detect some skipped steps, then maybe we can go into the PID control of this. For some reason, this always fails. Okay, there we go. So, okay, it's not asymmetrical. I don't know why I did that. Okay, here we go. So you have. Oh, I also have put in a little overhead view, which is nice. Okay, so yellow is clock, right? Well, I guess we'll find out. I'm pretty sure yellow is clock. So plug that in there. Bad boy. Naughty, naughty boy. Okay, and then power. Great. Now we take this and we slide it onto here. Nice. Great. That part of this assembly actually is not so bad. Okay, so what we want to do here is to make sure that we got micro pico on here. So here, stepper. All right, so the first thing we're going to do is we're going to just check if this works, because I'm pretty sure I unplugged this thing or something. Yeah, I don't know why I did that. I think it was because I didn't want loose shit lying around. Alright. So apparently we don't have Python, but christening the ship again. Alright, so we just plugged in this. I swear the worst thing about these projects, seriously, is the annoyance of having to deal with so many wires. Because wires seem like a NP hard problem. Like minimizing that seems like a very difficult problem. Alright, anyways, so while Python's installing, we don't actually need Python. Oh, wait. This probably will fail for some reason. Okay, that's not even relevant. But, okay, anyways, let's try to... So that just fails. So, I forget exactly how we do this. We have to install it, right? Use MicroPython online? Oh, it's an emulator. PYB. Oh, they have an official board for MicroPython? That's interesting. It's so small, too. Wait, is that a display controller? Dude, I've never seen this before. Oh, wait, hold on. My bad. This is so sick. How much does it cost? 2 DACs. Oh, wow, it's got ADCs in it? That's great. Could make my little synthesizer on this. Whoa, it's got a 3-axis accelerometer. Dude, what the fuck is this thing designed for? It's probably like $40. Yeah. Yeah, this is an expensive board. And you don't get the headers on it, do you? It comes in a little case. What the hell, man? That's fun. But, getting started. But don't we need ampy? How do we do this? It's all ampy, right? Let's see. Let's just read the instructions. Flashed. I definitely have MicroPico firmware flashed onto it. But, let's just do Thonny. If we install Thonny, it probably, installs MicroPython. But it's gonna give me another freaking Python install. I think it's just Ampy though, right? Ampy MicroPython tool. How do I install it? You install it with pip. On Windows, do this. Alright, so let's try that. Let's just make sure that we got Python. Great. What the hell? How do you get out of this thing? Controls. What? I thought for sure it was. Oh, Control Z. What? Dude, when did they do that? What the fuck is that? Control Z plus return? Dude, the people at Python are doing some nonsense. Okay, wait. So that means that Ampy will not be on the path. Why don't they just ask me... Is this... Let's open this up. Okay, so this is... Okay, so we do want to add this to the path. It's unfortunate because this is some long-ass path, and somehow the length of the fucking thing is like... Whatever, I don't really care. It's not user. We want to go here, new, and then you can't just Control V because why would you be able to Control V? Okay, so now we have Ampy, but let's open up Thonny. Thonny should get everything righted. Okay, so we want to do configure interpreter. Wait, no. This is just the IDE. How do we get it set up? Let me just ask GPT. This is stupid. Dude, what? Oh, I'm not logged in. Whatever. Wait, how do I... Okay, let me just read the fucking... Where's MicroPico? Requirements, VS Code, Python. Oh wait, let's try to restart VS Code then. No, yeah, there's still something. Let's see what. Where is it? Output. Installed stubs are already up to date. What is Ampy again? Oh, yeah. What? Oh, wait, this is the wrong one. Okay. For fuck's sake. I thought there was like a connect. Let's see here. Okay, yeah, this is what I guess I was looking for. Okay, so that's just add the microfirmware Pico. Oh, wait. But we already have it installed. I guess maybe we'll flash it again. We might as well flash it again. Okay, so we got to plug this thing in. So if you've never used, you'll need to find the boot cell, press the boot cell, and hold it while you connect the other end to your computer. Oh, shit. It's going to be a pain in the ass to do this. Okay. What we should do is... yeah, I need like a long hub. That would make life a lot easier. Okay, wait, I gotta hold down boot cell. Alright, great. So now it's... Oh, you can't see that notification, but now it says that it's what does this even say? It just goes to raspberrypi.com. Okay. So this puts it into mass storage mode. And if I don't, you will see the version of Python that you're currently using. Install MicroPython. Yes, it's this. It's the Pico W install. So this probably puts it somewhere, but then okay, we installed it. Let's see if we can connect in Thonny. So wait, this is, we want to be on here. Uh-oh. God damn it. What the hell? Oh, yeah. Okay, great. So we're all good now. Cool. We can get rid of Thonny, which stinks. So now, okay, so whatever. So that code that I just ran is running on my Raspberry Pi Pico. So now we should be able to run this code. And this will just test... okay, so let's just run this. Okay, great. So now, in this huge tangled mess of code... Oh, I guess... Bro, how is this still so tangled? Jesus. In any case, just based on that sound, you should be able to hear that this stepper motor is working. Anyways, what I want to do is get on to... okay, so we... can we... Is there an import system? Can we import the thing? Alright, let's just... Okay, let's just check stall.py. So what we want to do, just to start out with, is the bit depth. So you can see here in angle.py that the bit depth this is actually the bit depth of the chip is 12. So and there's 360 degrees, right? So that should mean that the number of possible readings it has per angle is going to be 2 to the 12 by so this is the number of degrees that it should, and the stepper motor is 1.8. 1.8. So by the pigeonhole principle, we should always get, like, for each step we should always get a new reading. The problem is there is some jitter, but so what we're gonna do is we are gonna copy over this. I'm gonna copy over this. So we're gonna do this, and then we're gonna go to here, and we are going to do this. Pulse with I squared C. Okay, I don't even think it gets used. All right, so great. So now we have a stepper. So let's put all the functions up here. All right, so now we have a stepper and an angle thing. Now we want to get, I'm gonna go to the bathroom and get some coffee. Okay. All right. So now we have the thing. So we want to basically write some code that instead of just test stepper, how does this work? Let's see, is there a library for stepper? Do this. If I just left the step pin high, though, would it continually take steps, or does it only do one? Okay. So it's on a rising edge that a step occurs. So let's just do this. As dumb as possible, it's going to be yaw step dot value 1 sleep 0.000, let's see, 001. What is that? That's 1 millisecond. Okay, so I should just be able to. Oh, actually, this sucks. We need to put this in a class, man. I had some code for that somewhere else, but I don't know. Okay, wait, let's make sure this is still working. Oops. What's going on? Soft reset done, but it's not. Oh, we are connected. Okay, wait. So if I just do take step, does it work? Take step is not defined. What? That's weird. But can I define functions in here? What? Yaw step is not defined. I don't get that at all. Let's just by the way, I don't think that this actually matters, so I'm going to just get rid of it. Alright, so I'm just gonna close this and reopen it. Sometimes I don't know, I feel like maybe I'm overly sensitive to doing that. Okay, so now let's just connect it again. And then if we run this, I heard a little sound, but now presumably this is defined. I don't understand that. if I were to, okay, but if I copy this, is it doing something? It's totally frozen. Ay, ay, ay. Why did an exception occur? Okay, I don't really get that. Run must do something else, I feel like. What happens if I just do this? If I just copy in this? Is it running? See, it's in some weird state. I don't know. I feel like, alright. I feel like, God, this is so fucking annoying. I swear to God, there's no way that this is functioning properly. Okay, let's just do this. Make sure this works. Does it? Okay, well, hold on. I'm gonna kill this. I'm gonna open up Thonny. Let's just see if the Thonny. Okay, if we close this, it releases, right? There we go. See, in some ways, this thing is actually better. Let's open that up again. And then, so let's just copy this whole fucking thing in. I don't know what the deal is. Oh, I hate that sound. Okay, so now I should be able to do... Great. You should hear that. So, okay, so now what we want to do is we want to get angle. We need to do the whole correction thing. So get angle just, but if I run this in a, oops. How do I disable that fucking, oh, what happened? Do I really have to add this stupid const thing? No way. There is no way that's real. Okay, let's run this thing again. Is it possible that it's not right? Dope. What the fuck? We'll just flip it around, maybe. No, it probably is that. Let's try it again. Alright, cool. So we did it. Yeah, so I just had it flipped around. Alright, so get angle, take step, get angle. And so we should, well, here's what we'll do. Wait, what is take step return? Okay, so you can see that the, okay, great. So now, if I were to hold it in place, I don't know if I could. Yeah, for a single step, it's going to be hard to hold it in place. Okay. Let's just print a little flag. I know that I have a flag, but I think it's, okay. Just go here. New part. This is just going to be a stepper hat, right? And then if we go to stepper, and we look at the length of this arc, I think it tells you the radius, but it does tell you the length of the arc. Okay, it does tell you the length. So, okay, so pi r squared, so 2.5 squared times pi. So that's 19 is 360. So then we want 12.49 divided by this. So this is the, so, and then times 360. So that's the number of degrees. Does that actually help us though? Maybe it does. The thing is, it does need to, so let's go back to stepper hat, open a new browser tab. Okay, so it's do we really want to make a flag for this thing? Or do I just want to make a cylinder with a set screw hole? Let's just do that. Alright, so this is going to be 5.2. And then let's make it 5.3, just to be safe. Because we're going to use a set screw anyways. And then in here, let's just make the walls 2 so it prints quickly. So this is going to be 2. So then you're going to extrude this by, I don't know, 20. And it's just going to go all around, but then somewhere in here, and then we can cap it off and put a little flag on it. So that's what we'll do. But, alright, so let's just do that. So sketch on here, this and this, and we're going to extrude it by like 5. And then sketch, so we're gonna, now we got to make a plane, tangent. It doesn't really matter which one it is. Oh my God. Okay, so it's this. So we sketch on here. Okay, so all we want to do is make a little rectangle. So can we use this? Okay. Oh wait, how do you midpoint these two things? I think I can just do shit. What is it? Point, Shift S. Then I could take this and do Shift M. Okay, there you go. So now we just want to make this like yeah, 4 seems fine. And then this, yeah, 2 seems fine. I mean, really, this part does not matter whatsoever. So we just need to do this, add. It's gonna be like a 10, but it's gonna be a second end position. This is gonna be, yeah, this just needs to be like 3, and then it's gonna merge with this part. So that's all we need to do. So basically, this will allow me to stall it. Maybe I'm gonna make it like 15. Just so that I have like real leverage on it to stall it. And then we just need to add the set screw. So we might as well add the set screw down here. So we'll sketch again on this plane. It gets rid of all of them. Oops. Okay, so now we just want to put, so how tall did we make this extrusion? Is it that? This was 5, so we need to be at least 5 down. Okay, so let's do this. And then we want it to be Is it M4, M5 hole? Just M5 hole. M5 hole. Okay, and then, come on, and then the distance from, actually, let's do the distance from here to here, like this, and let's just say 8. That seems good. So now we just need to bore through this thing to, oh, this is actually wider than that. Okay, cool. So we're getting there. This needs to be 2. Is that right? No, that doesn't seem right. Wait. First off, we need clearance. Okay, so yeah, so we need clearance. So this is going to be 0.15. Then from here, but then so we need a right. So what we would okay. I'm suspicious, but I think what we want to do is we want to take this, or wait, hold on. Yeah, that. Oh, wait. Yeah. No, but we don't want this circle. Why are the planes showing up when I don't want them to? So okay, so I think I just want to do this, not that, this, and this. Alright, what happens if I extrude that? Yeah, so that should be fine. Now let's just add the flag. So I started over because I didn't really like what was going on there. Because the reason I couldn't get a nut, in there, which would be the only reason why a set screw would work. So not really a good plan. Okay, so let's just sketch on here. So we just need to take this, extrude it by 5, Okay, do the same freaking thing again, over and over and over again. So we just need to tangent plane, tangent this thing. Great. Sketch on here. Are we on the right side of it? Okay. Alright, so we're going to get a circle in here, and we're going to get a rectangle in here. And then we're going to get a point in here on this midpoint. I'm going to take this and say Shift M. Great. Then we're going to say this is going to be, 4. This is going to be 2. Great. This is going to be 8. And, wait, we don't need a hole here anymore. I don't know what I'm talking about. Okay, so we can just extrude this by 15. And we got to go second end position, and this is going to be 2. And now we can join it. Great. Now we got our flag. And now the print orientation will obviously be like that. So this part is done. So just rename this to be stepper hat export. That's interesting. I've never seen that before. Okay, I just go with their default. Auto, range, slice. Okay, wait, hold on. This is not right. BBL. Oh, BBL. Oh, shit. Wait, what are we doing here? We're on... Whoa, is this synced to my cloud? That's super cool. So P1S 0.4. That's where we're at here. Textured PEI plate. We are using standard. I don't know what this BBL is. I guess that's right. First time printing. Alright, it takes 15 minutes. Okay, so we'll see if this works. It hasn't synced my AMS thing. There we go. Let's just look at the device. Alright. Fantastic. So, okay. So, since it seems like... And actually, could we, let's just do a sampling now. So, let's just do 20. And what we want to do is, so wait, we're going to get the angle. Yeah, so hold on. Okay, so A1 equals this. We take a step, A2 equals this. And then we say r.push append. I thought there was a push. If there's a pop, there's no push? I don't remember. Append A1 minus A2. Oh, wait, but this is not going to be... right. We need to write all the code to we need to write all the code to but whatever. Let's just see if this works. But we need to close this. And let's do connect. Let's just run it. Okay, so see here, there is some variance in that. If we just open up a normal Python shell. See, I don't understand that. When you click run, why does it not... What is that? Okay, I don't know, but that's so annoying. Okay, so that didn't fix it either. In any case, oh, but that is cool that it does like an ampy ls command so that you can see what's in it. Let's see what's in that folder. Yeah, so there's nothing in that folder, but I guarantee you that if I did an ampy transfer, it would see it or something. So that's okay. Let's just go yeah, so bro, what the hell? Is that for real? Import statistics. You have to call. Dude, Python is such a joke. Okay, all right, but the mean is close to 1.8 degrees, so at least the encoder is seeing what should be happening in practice. I want to look through this guy's code. Does he have PID? So we can close this. We can close this. We can close this. This. Okay. There's no PID in this example. I guess my right, so we'll definitely need to do this. I don't know why he needs a quadrant tracking thing. Yeah, so what I'm going to do is basically this is oh, so okay, so this is the same thing is okay. He actually saved some processing by making that a constant. Because if you're doing this every time, you know, it's a divide and a mul, but I don't honestly know how much that's gonna affect anything. All right, so what is the next step here? The next step is just, does he have the PID control thing? Let's watch the video, I think. Wait, but I want to do this because I'm trying to make my stream, it makes it less interesting, but it also makes my data cleaner if I don't have you guys able to listen to it. Where are my headphones at? All right, so I have these. But this doesn't turn off the... Okay. Custom DRO. Dude, this guy has hammered the fucking rotary encoder space. That's awesome, dude. Dude, this guy is sick.
But of course, it works the other way as well. And you can also see it on the RPM value.
Wow. Okay. Can we go to... I thought I had the video open. Son of a bitch. Wait, where's the PID one? Oh my god. These they just love to bother you. That's the great part about Windows. They just love bothering you. I think he goes into the code, right?
This video is sponsored by PCBWay.
Here we go.
A previous video on this development platform, I will do the explanation a bit.
Okay, so before I... Wait, what? What is this suggestion? The current bitrate is lower. Wait, hold on. Wait, hold on. Well, it's nice that I can pop that out. That's actually nice to know about. Audio bitrate. It's at 160, so seems fine. I think it just dipped for a second. Okay. Help me understand how you can do PID. Wait, we need a login so I can save all this shit. Dude, look at this. Firefox is literally unusable. There's no way that this happens in Chrome. Ay. Whatever. Help me understand how to do PID control with a stepper motor. I have a magnetic encoder on it, but conceptually, what is it that you're controlling? Because you have to step individual steps to reduce the error. So I just don't really understand how that works. Let's see if it knows what the hell I'm talking about. Right. Okay. I guess our jitter error would have to be the resolution of the. Oh, actually, we could dynamically change the microstepping. Like, that's actually not a problem. Yeah. So the PID algorithm adjusts the stepping rate and direction. So you have a set point, you have the actual position, and then you have the error. Oh. Okay. This is the worst sound. Yeah, so we just need to sound none. Okay, so now if we do this. Fantastic. That sound just bothers the hell out of me, bro. It just always plays. Okay. Because I was thinking that maybe what you're actually controlling is, yeah, the direction, but mainly the delay in between steps. Okay, let's just watch the fucking video. Okay, so I think maybe let's just go back and try to okay, so here's what we're gonna do. We're going to take step, then we're gonna get the angle, and then this is going to be the 0. So let's go. I know that he has the code for this, so let's just read this. So we can just copy that. Okay, yeah. So what does this thing do? Check magnet presence. Oh, that's cool. Yeah, I feel like we don't need to do that. I feel like I just assume that it's right. So, yeah. So we do need a number of turns. We need the corrected angle. This is going to be the real value. Start angle. Okay, so he sets them all to 0 and then he just overwrites them. Okay, this is all OLED stuff. Okay, here's start angle is equal to degree angle. So if we are just going to adapt this. Wait, we should probably verify that this is, okay, so here's the main loop. Read raw angle, correct the angle, check the quadrant, and then refresh the display. So what does his read raw angle do? Deg angle. What does it return though? It writes raw angle and deg angle, but it's deg angle. Oh, here's deg angle. So wait, does read angle? Yeah. So wait. Yeah. So let's break this up. So get raw angle. And then we could just do a get def get angle, and this does to deg of get raw angle. Oh, I hate Python. You have to return. You can't. You have to explicitly return. Okay, so there's just some helpers. So what read raw angle doesn't actually return anything. He writes his code kind of weird, just by mutating a bunch of globals. Embedded programming is so random. Here, we can do this too. So that speeds something up, but that's like goofy optimization shit that's really not that important. All right, so we got the degree angle, and this is in the function. You know what, can we just copy this whole thing? Then I can get some, I don't have Arduino installed on here though. I hate Arduino, bro. Arduino is so lame. But honestly, the point is this gonna work? Is this how this works? No way. Okay. Let's just start to copy this. Wait, let's put this all down here. Num turns equals 0, corrected angle equals 0. Alright, so now we have all of his little things. And, okay, what is the setup? The setup is read raw angle, start angle equals dig angle. Okay. Yeah, so I feel like all I have to do is do this. Start angle equals get angle. And we take a step just in case the reading is weird. Because I remember that when we ran this or something, I was getting like a bunch of really noisy values just at the beginning, but then once I started turning it, it was fine. So hopefully this does something just to make sure that we are correct, or righted. Okay. Now the loop, it reads the raw angle. So now, okay, so let's just okay, then so now we need to do a def correct angle A. Okay, what is the correct? Okay, so this basically, gosh, this code is so long for something that's in Python is written literally as this. I don't know if that's actually true, but seems like it. Okay. Now the correct angle, here's what we want to read. Okay, so this is the thing that we're reading. Yeah, so is equal to A minus start angle. This tears it. If C less than 0, C plus equals 360. Else, we don't even need this. Okay. So that's the whole, and then we just return C. All right. So yeah, so we just keep it positive. So that's easy enough. And then what does he do? After he does the correct angle, he checks quadrant. So I'm down to just like kind of copy this code. Check quadrant. And I don't like these globals. I like passing around data because then at least the functions are a little more pure. So, all right, so let's just, can you do this in Python? Or do you have to do 1 is less than 2 is less than 3? I don't even, I hate that shit. I hate that. That's so, I don't know. You know what? Maybe it implicitly puts parentheses around it. No, but that doesn't make any sense, because if you were to do this, then it would be true is less than 3. Oh my, give me a break, bro. That's so silly. Yeah, no, but that's not how that, yeah, it's that's not how things should work. If C is greater than or equal to 0, and then is it a double and? I think it's just and, right? And C is less than or equal to 9. I'm just going to copy this code because, so then we're going to say Okay, we'll say, what about a get quadrant function? Instead of just writing it globally, it's possible that he's doing this because of these interrupts or something. Because I know that they're... All right, I'll be back in a second. Okay, I'm back. So check quadrant. What does it actually do? It's going to mutate some random state. So it mutates the total angle thing. Global. Right. So it just... All right, I'm down to just use this thing. So so we didn't actually put those in. Yeah, so we need to say quad equals 0, prev quad equals 0. Quad equals 1. Elif C is greater than 90 and C is less than or equal to 180. Quad equal 2. Elif C greater than 180 and C is less than or equal to 270. Quad equals 3. And then elif, he does them as separate ifs. I don't think it should matter. They should be exclusive. Okay, fine. Quad is not accessed. Can you do that? Let's say a equals 5. Def foo a equals 4. Foo a. Uh-oh. This is running in a MicroPython kernel. How can I mutate globals? Declare A as global. Does that work? So then that means that we need to, okay. All right, so let's try that again. Def foo global A equals 4, foo, A. Okay, great, cool. So that's how you do that. I didn't even know that. So then we need to say global quad. How do we go back to the code? There we go. Okay. And we also want to do global prev quad. I don't know if, can you do multiple of them? Let's do a test. A equals 4, A equals 5, B equals 6. Def foo global A, B. A equals 1, B equals 2, foo. Okay, great. So we can just okay, great. Then yeah, so num term turns plus equals 1. Right, yeah, and then if and prev quad equal to 1. Great. Okay, but that's not the end of the function. Correct angle. Wait. This takes a C, right? His check quadrant doesn't take a C, so we're just gonna say plus C. We should be able to delete that. Okay, so now, what is his loop? Okay, so while true, C is this. This reads it and corrects it is just the 0 offset. This is just right, but then and let's why not do a return? Print total angle. Sleep 10 milliseconds. Okay, so now we're going to try to run this code. Okay, so it's reading 0. Oh, but we've locked the how do we see, because now it's set to 0. What if we just comment this out? and comment this out. And then we run this. Okay, so we're at 0. Oh, but it's still locked in place. Is it locked in place even after? Okay, so the stepper motor is locked, and I was hoping that I could. Well, why don't we do this? Why don't we just undo that, and then we do take step has the delay in it. Great. So we just need to and let's actually just because that's a long delay, but that's okay. So then we're gonna say for I in range 200 take step, or 200 is high. Let's say 10, and then let's run this. Oh, so that is absolute. That's great. It's working. Okay, cool. All right, so now it's time to look into the so let me just say this. So we have so this isn't actually a check stall code. But it is absolute position. So that works out pretty well. Is there no formatter? What the heck? That's crazy. Really? Pylance doesn't have a formatter in it? That's actually wild, dude. What the fuck? Writing Python's such a joke. Okay, so now we just need to go back to this and see how he does the Okay, so actually, hold on. How about we could just do P control, so just proportional control. So basically the idea would be we could just do like set point equals, and we want to go to like, let's say we want to go to 750 degrees. When we run this, this is going to be 0 at the beginning. So then error, so then what we do is, I'm going to comment this out. I'm going to say error equals t minus, and we need to know the direction. So this is going to be negative. So we need to set the dir appropriately. So I think it's just going to be if error less than 0, dir dot yaw dir dot value 1. Let's see, what does it start out as? I don't know, maybe that's wrong. And then P is equal to okay, so what is this going to be? This is going to be the number of steps that it needs to take int of, let's just say kp, let's just say kp equals 1. So this is going to be int of kp. Oh, wait, let's just check that int of 0.5 does something. Okay. Kp times error. And then we want this to be abs, right? Because we set the direction here, so this is going to be abs int. Okay, so then here, this is going to be p. So this is going to take 750 steps. Let's make it 0.1. And then wait, if abs error less than 1, how about that? So this is the jitter. So jitter. So it doesn't bounce around. It just waits a little bit. And then if the error is less than 0, it switches the if error greater than 0. Presumably you would want a last prev thing to like only do this on changes. Then we'd say yaw dir that value 0. We probably will have to flip these around. So now what we want to do is we want to here we want to print, and we can't do f strings, right? I don't know how you do this. So oh, I think I can say t air. Oh, I need to do this. Air. And then set point. Let's see if that works. Oh wait, let's figure out P. So how many steps it's taking? Okay, so let's just look at some of these readings and see what the heck is going on. So okay, T was at 0 and the set point was to go 750 degrees. So then it went to 226 and the error got lower. But then why did it switch back? It shouldn't have switched back. Let's try to run it again where this is 0 and this is 1. I don't know if that's right, because that seems a little bit fishy. Hey! That was pretty good, bro. That was pretty good. Let's make it 0.2. And let's make the delay lower. Let's make it twice as fast. Wait, what? But the error, okay, so the problem is here, the error is 98. Oh, interesting, because int rounds it freaking down. How do you fix that? Wait, so the problem is this. Wait. The error if we do, okay, so step error is equal to error divided by 1.8. Let's, okay. So this needs to be KP times step error. But that still doesn't get rid of the fact that yeah, let's run it again. Right, so oh, I see. So the problem is though, if you take more than you can, the maximum number of steps you can take is going to be 90 over 1.8. So we need to do so P equals min this P. And we actually probably want to do like oh, but then you gotta all right. Not bad. How do you get a random number between Python rand number between -1000 and 1000? Brand int? No. There we go. Let's see if that actually is there a, let's see, MicroPython standard library. Let's just look up random. Presumably we can do this. Randint uniform. Oh yeah, okay, cool. All right, let's run it. Wait, the error is what? So presumably the so wait, let's just copy this. Oh, you know what? Yeah, just because it didn't get to that print thing. But it actually is approaching the control point really well. All right, so we did proportional control. I think. I mean, this seems like proportional control. So wait. Right, you see here, so we limit it to 48 steps. But actually, wait, 48? Yeah, that should be right. Because we need to make sure that the quadrant things work out. Okay, so let's rename this to proportional control. And let's commit this code. The point. Oh, hey, wait! I can go get my printed part. All right, so wait, I'll be back in like 1 second. I printed a small part so we can check for stalls, and I'm gonna try to get it on camera, showing that it will, when it stalls, it'll still go to the right spot. All right, I'll be back in a second. Oh, I need my keys. Okay. Unfortunately, I should have just, I cleaned it out, but I got a bunch of spaghetti. I'm going to try to reprint it, see if that works, but this thing got totally fucked. I don't know what happened. I was, worried about it, but, there's no reason I should be worried about this. These settings are totally fine. I don't know what happened. Maybe I should, just in case, should I put a brim on it, maybe? Where's the brim thing? Brim type auto. Outer brim. That stinks, man. Well, okay, but this thing is sick. This thing is awesome. So, the thing, though, is, this is still kind of too janky in my mind. Okay, well, let's just try to test it by hand. Oh, yeah, this thing's getting warm. Okay, wait, so we're going to do this. We're going to run it. Wait, why is it going the wrong way? See how the air is not changing because I'm stalling it? But why does it start going up again? Wait, this seems wrong. Did it overflow or something? Okay, let's stop it. And let's try to flip these around. But I feel like it was doing the right thing. That's why I'm so confused. But maybe that's just because I was getting only positive ones or something. No, yeah, this is wrong. What the hell? So okay, so there's some weird bug in here. Okay, wait. So um it seems like it's doing the right thing. But why does it... That's so weird. I don't understand that at all, because like why would it only sometimes do the thing? Oh, because it's stuck here. The error is above 1. Right, but okay, so we need to make this less than 1.8. That's what we need to do. Because that's what... Okay, I get it. That checks out. Okay, so let me switch to the overhead camera and see if you can see this. You can't because I don't have a freaking flag, but basically... Or why don't I just do this? Hold on. Okay, so you hear my audio, and now video capture device, and I think it's 1. Yeah, and then it's full screen it. Okay. Uh-oh, I unplugged something. Let's try it again. Nah, I fucked something up. Hold on, let's take this out of here. I was holding it, that's why. I don't know what I did. Oh, there we go. Okay, it was just loose on this end. Alright, we're good. Let's slide this thing back. Oh, wait, here. Okay, let's slide this thing back on here. Honestly, I don't hate this design. Okay, so we should be able to just rerun the code. This is awesome, dude. It picks some random number between minus 1,000 degrees and 1,000 degrees. And it goes there. And then if we stall it, it keeps going. Okay. Alright, so I feel like I'm going to end the stream, and when I come back, I'm going to make a short video, because, you know, I got to be posting, bro. This camera quality is not so bad either. I'm hoping today I'm going to try to sneak in either a GoPro or one of these cameras. I'd love to stream it, but I might just record it on the GoPro, so I probably got to plug that thing in right now. Okay, I think it's plugged in. So I'm hoping that I can get some lathe work, because they said I can't film in class, but as long as I'm like sneaky about it, I think I could get away with it. But if I'm at the lathe and I'm the only one in camera, I feel like, and I'm not recording audio, then, well, I will record audio and I just won't publish that. I feel like it'll be okay. Anyway, so that's the stream. Is we basically got positional control working. Let's add this. Fix the jitter. And let's push that code.